Our next example is about high school students. In a local high school of 500 students, there are 200 females, 100 sophomores, and 50 female sophomores. So before I start working on this problem, let me actually write down the letter representation of these different events. So I'm going to use F to mean female. So hence I'm going to use M to mean male. S to mean sophomore. So if I look at these numbers, the total number of students that is given to us is 500. So I will say that. Then I will say the number of female, that's 200. Number of sophomore is 100. So I can say that the number of male is 300. And the last information is number of female and sophomore, because it says that number of female sophomores are both female and sophomore, so I will use intersection, and that number is 50. So these are my premise, and I'm going to start working on the problems. So the first question is asking me, what is the probability if we choose a random person, then that person is female or a sophomore? Remember, or is union, so you're saying probability of female or sophomore. So that's probability of female plus probability of sophomore minus probability of female intersection sophomore. So I will do it by the numbers. This is 200 over 500 plus 100 over 500 minus 50 over 500, and I will get 300 minus 50. So 250 over 500, that's 1/2, so 0.5. The second question is asking me, what is the probability that a randomly selected person is going to be male or sophomore? So male or sophomore will be probability of male plus probability of sophomore minus probability of male and sophomore. So we didn't find male and sophomore. Remember, there are a total of 100 sophomore. If 50 of them are female, the number of male sophomores, which is male and sophomore, should be 50 as well. So I have all the numbers. This is 300 over 500 plus 100 over 500 minus 50 over 500. So I get 400 minus 50, so 350 over 500. And that means I can divide both top and bottom by 50 and get 7 over 10. So this is 0.7. The third one is asking me, find the probability that a randomly chosen student is a female or is not a sophomore. So this is interesting. See how I write it. Probability of female or not a sophomore is sophomore complement. So S24C is not a sophomore. Well, so I'm going to find out how many female are there to get probability of female plus probability of not sophomore, how many of them are there, plus probability of female and not sophomore, how many of them are there. So let's find them out first. So remember, not sophomore, if number of sophomore is 100, the number of not sophomore is 400. If number of female sophomore is 50 and total number of female student is 200, the number of not female sophomore is 150. So I will say female and not sophomore is 150. So now I have all the numbers. So I'll say that probability of female is 200 over 500. So not sophomore is 400 over 500 minus female and sophomore, not sophomore, is 150 over 500. So you get 600 minus 150 is 350. So just like the last one, over 500, which is going to be 7 over 10, and hence 0.7 is the required probability. Answers my question. Halloween candy. At Halloween, the accent is on test of the candy, that is, in a sample of 100 children, 70 like chocolate bars. So I'm going to see C for chocolate bars. And I would say number of C is 70. 60 like peanut butter cups. So P is going to be peanut butter cups for us. And we know the numbers. So I'm going to call it B because otherwise I will confuse it with the probability P. So number of peanut butter cups is going to be 60. And then the third condition is 50 like both. So number of chocolate bars and peanut butter cups. So and I used intersection is 50. So let's see whether we can find the probabilities. What is the probability that child likes either chocolate bar or peanut butter cups? So again, addition rule, this is probability of C plus probability of B minus probability of C intersection B. So I know all these numbers. This is going to be 70 over 100 total number of children plus 60 over 100 minus the intersection should be 50 over 100. So you get 130 minus 50 is 80 over 100 and that's 0.8, the required probability. The second question is a bit interesting. It says, in part A, suppose you forgot to subtract the probability of the intersection, how would you know that your answer is wrong? So let's intentionally forget to subtract what we get. We get 70 over 100 plus 60 over 100, and that's 130 over 100, so you get 1.3, which is greater than 1, and then I know probability values cannot be greater than 1. And that answers my question. Hence, I get to say that my answer is wrong. All right, we'll carry on. Our next example is picking a card. If we draw a single card at random from a deck of 52 playing cards, find the probability that the card, so the first one says, the card is heart or diamond. I'm just going to abbreviate by the first letter. Probability of heart or diamond should be probability of hearts plus probability of diamonds minus probability of heart and diamond. Remember, there are 13 hearts, so 13 over 52, 13 diamonds, so 13 over 52, and there is no card which is both heart and diamond, so this is 0. Even though there is an intersection, it should be 0. So I get 26 over 52, which is 1/2, that's 0.5, answers my question. Second one, what is the probability the card is red card or a jack? So probability of a red card or a jack. So this is probability of being the red card or probability of being jack or minus probability of being both red and jack. Remember, there are 26 red cards, so 26 over 52 plus 4 jacks, one of each suit. And there are 2 red jacks, one diamond jack and the other one is heart jack. So 2 red jack. So I get 30 minus 2, so 28 over 52. And that should be 7 over 13. And I can use my calculator to simplify this number to 4 decimal places rounded. 7 over 13 should be 0.5385. The third question is asking you, what is the probability that the card is a club or a fess card? Club or fess? Probability of club plus probability of fess minus probability of club and fess. Well, probability of club, there are 13 clubs, so 13 over 52. Fess card, so there is king, queen and jack of each suit, so 3 in each suit. So 4 times 3, 12 of them. 12 over 52 minus how many club face cards are there? Well, club king, club queen, and club jack. So there are exactly 3 of them, so it's 3 over 52. So I get 25 minus 3, which is 22 over 52, and that's 11 over 26. So let's see how much 4 decimal places it's going to look like. 0.4231 is your answer. And we carry on to D, heart and diamond. Probability of heart and diamond can't happen. A card cannot be heart and diamond at the same time. So this is going to be 0. Probability of not a spade. How do you write it? Spade is S, not a spade is S complement. So use the complementation rule. This is 1 minus probability of being a spade. So this is 1 minus, there are only 13 spades. So I get 52 minus 13 over 52, and that's 39 over 52. I can simplify that as 3 over 4, which is 0.75, the required probability to this question. All right, we carry on to our next problem, new sonata. Music researchers have discovered that a new sonata from the classical period of the late 18th century, the probability that the sonata was written by the following composers is as follows. Mozart, so I'm going to use M for Mozart, is 35%. I'm going to use Haydn, H, and we will say that that's 50%. So as soon as I say that, you can go ahead and say that these probabilities are 0.35, this is 0.5. And finally, we have Beethoven. So I'm going to say B for Beethoven. And that is 15%. So in probability terms, this is 0.15. It is known that composers are mutually exclusive. That means no sonata is written by more than one composer. What does it tell you? All the intersections are 0. No composition is written by more than one composer means the intersection in the probability are going to be 0 in the addition rule. So first problem is asking you, find the probability that the sonata is either Mozart or Haydn. Probability of Mozart or Haydn. So I will simply say this is probability of Mozart plus probability of Haydn because the composers have no intersection, they're mutually exclusive. So probability of Mozart is 0.35, probability of Haydn is 0.5, your answer is 0.85. Second one, what is the probability that the sonata is written by either Mozart or Beethoven? Probability of Mozart or Beethoven, and that should be equal to probability of Mozart plus probability of Beethoven, but no intersection again. So you get 0.35 plus 0.15, and that's 0.5 answer to the question. Third one, the sonata was written by either Haydn or Beethoven. So probability of Haydn or Beethoven. Again, remember there is no intersection. So probability of Haydn plus probability of Beethoven, and that's going to be 0.5 plus 0.15, so that's 0.65. Pretty simple. Final one is the sonata was written by both Mozart and Haydn. So probability of Mozart and Haydn, as I have said, there is no intersection, so I will clearly write down that is 0, and that will complete the answering to the question. So we'll carry on to similar examples. These type of examples are called Venn diagram. Helen is considering buying a new car. The set of cars she is considering is shown by the Venn diagram below. Within this set, the set A contains cars made by Toyota. The set B contains cars made by that are blue, and the C contains cars that are manual gearbox. The subsets A, B, C, D, E, F, and G are defined by the boundaries in which they are located in the diagram. So what are my questions? The first question is, select the correct set that corresponds to each of the following car choices. Part 1. Blue Toyota cars with manual gearbox. So I want blue. Blue is B, so I should be in the B circle. Toyota, so I should be in the A circle. Manual gearbox, so I should be in the C circle. So which is the portion that is in all of A, B, and C? So that is the overlap of all three of these things. So I will say my answer is going to be E. Part 2 is asking you Toyota cars that are blue without manual gearbox. So now I want Toyota cars that doesn't have manual gearbox. So I want the overlap of A and B, but it cannot have manual gearbox. So that should be only this portion. And you know that that is B, so you will go ahead and answer your question for this one. The right option is going to be B. Final one is cars that are neither Toyotas nor have a manual gearbox. So cars that are neither Toyotas nor have a manual gearbox. So if I return to the picture, I do not want my car to be in A, or I do not want my car to have manual gearbox, so in C. Everything else I'm going to accept. So that should be the letter symbol C. And anything that is outside these three large circles. So let's see how we are going to answer this question. So basically we will say letter C because that's the only possible answer matching this thing. And we will say the letter C is the collection of all the cars that are not Toyota and doesn't have manual gearbox. Exactly what we are wanting. So this is a portion which is not in A, so not a Toyota, not in C, so not a manual gearbox, and hence my answer. One more problem. A sample space contains 7 sample points or outcomes. Let events A and B defined according to the Venn diagram below. So A is the event containing the sample points 1, 2, 3, 5, and 6, and B is containing 2, 3, 4, and 7. So I want to know what is probability of B. So as I said, probability of B is going to be probability of 2 plus probability of 3 plus probability of 4 plus probability of 7. The points there. So probability of 2, 3, 4, and 7. Probability of 2 and 3 is 0.05, 4 is 0.1, and 7 is 0.05. So 0.05 plus 0.05 plus 0.1 plus 0.05. Only probability of 4 is different. The other 3 are all 0.05. So I'm going to get probability of B equal to the sum of these things, which is 0.25. Probability of A bar. Remember, A bar is whatever is not in A. So not in A, I'm going to say this way, not in A complement, and in B. So look for those things that are not in A, but they're in B. So not in A, but in B are 4 and 7. So you will say this is probability of 4 plus probability of 7. So I'm going to go ahead and say that 0.1 plus 0.05. So this is 0.15, and that's my answer here. Probability of A union A complement. So not in A, at the same time in A. None. There is nothing that will be in A and outside of A at the same time. You cannot find anything that is both in A and not in A. So the probability is clearly 0. Finally, probability of A union B. Well, that is everything. Everything is in either A or B. So I will say this is probability of 1 plus probability of 2 plus probability of 3 plus probability of 4 plus probability of 5 plus probability of 6 plus probability of 7. And I know that probability of 1, 2, 3 and 7 are all 0.5, 4 and 5 are 0.1, and 6 is 0.6. So I will get 0.05 plus 0.05 plus 0.05, the first three, then 0.1 plus 0.1 plus 0.6 plus 0.05, and then I'm going to add them. So 0.05 plus 0.05 is 0.1, plus 0.05 is 0.15, 0.25, 0.35, 0.95. So the sum is 1, hence that's the probability of the union. So this is the end of the algebra of probability section. Next time we're going to talk about the last section in probability called the multiplication rule, dependence and independence of probabilistic events.